The last topic in the chapter is on polarizers and polarized light. And typically what you'll see is a problem where you have light that's either polarized or unpolarized initially that passes through one or more polarizers, and you want to know what's the amount of light that comes out the far side. So we've got unpolarized light in this problem. So unpolarized light has sort of random directions of the electric field in it, and it has some intensity, I0, and they don't tell us actually what the number is. Then it goes through two polarizers whose transmission axes are at 30 degrees with respect to each other. So let me draw them here. So here's polarizer 1. That's just for the sake of ease. Let's make polarizer 1 have its axis straight up. And then polarizer 2 over here, it has its axis at 30 degrees. Let me draw that approximately. So it's at 30 degrees to what our first one was. So we've got 30 degrees in there. Okay, so what's going to happen to the intensity of the light as we go through? And we know that our equation is that the intensity afterwards is equal to the initial intensity times the cosine squared of the angle between the incident light and the polarization axis. All right, so first we have unpolarized light going through a polarizer. So what we have, so we've got polarizer 1, polarizer 2. Each of them we're going to cut down on the intensity of light. So unpolarized going through a polarizer, what happens is you just drop half of the light. So we're going to go down from an intensity of I0, whatever it is, to an intensity of I0 over 2. All right, so what's going to happen for the second one? Well, I2, we're going to use our equation. I2 is going to be equal to the incident light intensity I1 times cos squared of 30. Okay, and cos squared of 30, remember cosine of 30, if you learned the unit circle, cosine of 30 is root 3 over 2. So cos squared, cosine of 30 squared is going to be the square of that. So that's going to be square the top, root 3 squared is 3, square the bottom, 2 squared is 4. So that's going to be I1 times 3/4. All right, so I2 is equal to 3/4 of I1, and I1 is half of I0, so we get 3 on top, 4 times 2 on the bottom, 3/8 of I0, so 3/8 of the initial transmitted light. So the initial light will be transmitted. Okay. And if you didn't know the unit circle enough to remember that cos 30 is root 3 over 2, you could have just plugged it into your calculator, squared it, and you would have got 0.75, which is 3/4.